Okay, today we're going to practice differentiating logs by differentiating ln of 2x cubed minus 3x plus 1 to the 99th. So if you just look at this, you might think, oh, okay, there's two chain rules here, right? This is the composite of three functions. This is f of g of h of x. And I guess it's actually the prime of f of g of h of x. And you could do that because you can just use the chain rule for three functions. You can do f prime of g of h of x times g prime of h of x times h prime of x. But that is the harder way. What we really need to do, if we want to do this quickly, is remember the log rule of the exponents. We need to remember that ln a to the x is the exact same thing as x times ln a. You can just pull the exponent on the log argument down. So we're just going to pull down that 99, and that'll make it really fast. Okay, so I did not mean to make that pink. Okay, so we are going to pull down the 99. This is going to become d by dx of 99 times ln of 2x cubed minus 3x plus 1. And because 99 is a constant, we can use the limit rule that you can pull a constant outside of the limit you're applying, and we can just pull that 99 outside of the d by dx, and then that becomes equals 99 times d by dx of ln of 2x cubed minus 3x plus 1. Now we can use the other log rule. I guess I don't know if it's more of a differentiation rule really, but it's when you're differentiating logs. The rule is that ln x prime is 1 over x. I'm going to write that up here. It's good to keep our rules all in the same place. d by dx of ln x is 1 over x. Those are the rules we're using today. All right. So now that means that we are going to, and also, mind you, this is still a composite function. So we are still going to use the chain rule. We're just not going to use a chain rule within a chain rule. So now we're going to do 99 times 1 over the inner function. So that's 1 over 2x cubed minus 3x plus 1 times the derivative of the inner function. So I'm just going to write 2x cubed minus 3x plus 1 prime. Make that the next step. So now we're going to end up with 99 times 1 over all of that. I'm just going to write all of that. I'll write it in the final solution. We don't need to write it down 4 times though. 1 over all of that times, and now this is just addition and subtraction, and we know that for subtraction and addition, the derivative of a sum is just the sum of its derivatives. So we're going to end up with 3 times 2x squared minus 3 times 1x to the 0th power plus 0. I'm only writing this out to make it super clear. When you know it, you can just skip over this. I mean, you can just do it in your head. Now we're going to go up to the right-hand side. Now what we've got is 99 times 1 over 2x cubed minus 3x plus 1 times 6x squared minus 3. And that is one chunk. Always put brackets around things, because when you lose them, you start to lose track of what you're supposed to be keeping together. Because these functions, these equations, actually, they're not functions. They get, usually they're not functions. They get very big, and then there's so many moving parts. Okay, so the next thing that we're going to do is we're just going to rewrite this. And we're going to let this equal y, and then the derivative, we're going to write it as dy over dx, which is the slope of the tangent line. So this is y derived. So it's kind of like, we would have been using implicit differentiation, but it's not really like those problems usually are. We don't have like ln of 2x cubed minus 3x plus 1 to the 99th equals 10. Then we would be using implicit differentiation. When we just are deriving something like this, we let it equal y, and then we're kind of deriving both sides because you're doing the same thing to both sides. And because you're deriving one side, you're deriving y as well. And that makes perfect sense because dy over dx is, like I said, the slope of the tangent line. So it's just like a different way of writing that we're finding the derivative of y. Okay, what color should I use? Okay, so now we end up with 99 times 6x squared minus 3 over 2x cubed minus 3x plus 1. And that is our solution.